Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Chemistry Paper 1 Higher Tier from 2021. Question number 6 is on the topic of chemical changes. Metal oxides are produced when metals are heated in air. A student investigated the change in mass when 0.12 gram of magnesium was heated in air. Now, this is actually a required practical for change in mass, and it's linked to law of conservation of mass. Figure 5 shows the apparatus. You have a crucible. Inside it is a magnesium. You have a lid to stop any magnesium oxide escaping. The student measured the mass of magnesium oxide produced using the balance, obviously. 0.12 gram of magnesium reacted to produce 0.2 gram of magnesium oxide. Calculate the number of moles of oxygen gas that reacted. Now, you started off with 0.12 gram of magnesium, and you wound up with 0.2 grams of magnesium oxide, which means mass of oxygen reacted is 0.2 minus 0.12, which is 0.08 grams. So they want the number of moles. Number of moles of oxygen is equal to the mass 0.08 divided by the relative formula mass of oxygen. Now oxygen is 16, but here we are talking about O2, so that's 16 times 2 is 32. So we'll have to divide that by 32, which gives us 0.62598. We can round it up to 3 decimal places, 0.626 moles. The student repeated the experiment without a lid on the crucible. Suggest why the mass of magnesium oxide produced would be different without a lid on the crucible. Now, why? So they haven't actually said whether it's gone up or down. So without a lid, the mass of again magnesium oxide, I'm writing the symbol, was or would be less. Reason being, since some of the products, which is magnesium oxide, escaped into the air. It's a fine white powder, so it can easily escape into the air. Copper reacts with oxygen to produce copper oxide. 63.5 grams of copper produces 79.5 grams of copper oxide. Calculate the mass of copper oxide produced when 0.5 grams of copper reacts with oxygen. So let's mass of copper oxide (79.5) divided by 63.5 times 0.5, which is 0.62598. Again, we can round it off to 0.626. The same answer now. I made a mistake in this calculation. I just realized that I was being lazy. So that is not the correct answer. So now this, sorry, this is 0.08 divided by 32 is 0.0025. That sounds better. 0.0025 moles. Instead of doing the calculation as I do the video, I wrote down the answers on the side by doing the calculations before, and I got it wrong. Iron reacts with oxygen to produce iron oxide. 0.015 moles of iron reacts with 0.01 moles of oxygen gas. Determine the formula of the iron oxide produced, the balance symbol equation for the reaction. Okay, so the 0.015 moles of iron reacts with oxygen to produce oxide of iron. So iron plus oxygen is going to give you FeO. Now we are trying to work out the formula for iron oxide. The reacting moles is 0.15, 0.15 and 0.01. So the mole ratio, if I divide ratio for iron is to oxygen is 3 is to 2. No, yeah, this is actually the other way around. That's okay. Right. That was right. 0.015, 0.01. So the ratio would be 3 is to 2 because iron would be 3 and oxygen is 2. So the ratio for iron to oxygen, just O, is 3 is to 4 because this was for O2. So the formula would be Fe3O4. So the balance symbol equation is going to be Fe plus O2 gives you Fe3O4, which means I would need to add 3 ions and 2 molecules of oxygen. Oh, they've given us the space here. Let me rewrite that. Fe3O4 and 3Fe plus 2O2 gives me Fe3O4. Now that brings us to the end of this question. I want to extend this just by doing it slightly different because I have a feeling that some of you might not understand. So iron is reacting and the mole ratio is 0.015. Oxygen gas, they are saying, because they are saying it's O2 gas here, is 0.01 moles. 0.01 moles. Now, if it was just oxygen, this would be double that. So it could be 0.02. Now, if I divide 0.02 divided by, so We write this bit. Fe is to O. I'm working out the formula for this. So I've got 0.015 is to 0.02. If I double this, it will become 0.03. And for me to get the same on this side, I will have to multiply it by 3 to get 0.03. So I've multiplied this side by 2. So that will be Fe2O3. 3. No, I want it to be 6. So I will need sorry, right. Let me redo that again. I'm making a big meal out of this. So I have 0.015 is to 0.02. The smaller number is 0.015. If I divide 0.02 divided by 0.015, I would get 1.33. Now to make this a whole number, I will have to multiply it by 3. If I multiply this by 3, I will get 4. So, which is why it is going to be Fe3O4. Right, that brings us to the end of the video. Sorry to have wasted your time. Hopefully you understood this slightly better.